Hey everyone, I hope you're all well, hope you're all safe. I get a feeling a lot of you won't really see this, but I'm going to try and keep up a routine anyway. So with the school currently closed right now, we can only really do review. Last time we met, we started a packet for review. It was a front and back for a page. We're going to look at that today, just to familiarize ourselves with the important terms. I'm also going to show you a tool I made with an online calculator that will help you solve quadratic problems at home, since I know probably most of you don't have a TI-84 graphing calculator. So this will help you with those. It does everything it needs for quadratic equations. All you need to do is identify the A, B, and C values. With that said, let's get started. So last time, which was a while ago, we had looked at this and we were solving a bunch of different problems to prepare for the test. We're going to look at this material again and go from there. Before you get started on this, before I continue, you really should pause the video and try some of these on your own. I'm going to walk us through one to start, and then after we go through one, try the rest on your own first using the calculator I gave you. I'll also do 3 since 3 is different. So for here, for number 1, we've typically been relying more on the quadratic equation or the quadratic formula. So we need to identify, and even just in general, we need to find our A, our B, and our C values. In this case, there's no number in front of x squared, so A is 1. In front of x is 2, B is 2, and then we have a negative 3 for C. Now, I'm going to switch over to my application, which is super helpful, but if I wanted to walk through this to start, I would know x is negative b over 2a. I'm going to post the review sheet as well to help us with that. But let's go switch over. If I can. So this is Desmos. It's an online graphing calculator. It does really everything you would need it to do. And I have it set up with A, B, and C first. So I'm going to go plug these in. So A was 1, B was 2, C was negative 3. I think. And double check. We're good. Now, this next line, number 4, all this does is actually graph our parabola. And we note, since A is positive, it is a smile. So we're good. Then, I have this Vx. This is our axis of symmetry, as we can see, since it's negative b over 2a. And then in the right, it tells us what our axis of symmetry is. So if I go back, my axis of symmetry is equal to -1. So now in my table, I know my middle point, the x will be -1. To find the vertex, I need an x, comma, y. Well, I know my x is -1. I could plug in -1, but I already set that up for you nicely. If we look, Vy is our y value for the vertex. I just plugged in Vx wherever I had x before, and I get Vy is -4. So our vertex is at -1, -4. Now let's go check this in the parabola. If we look, if I go click on the parabola, the vertex, here's the lowest point, is at -1, -4. I can go plug that in. And this is also -4 here. I'm going to go graph -1, -4. And now, this part might be a little bit harder now. But let's look. We've got, if I go over to 0, I've got -3. If I don't know if I'll be able to get this too well. If I get -2, I have -3. So these points are symmetric. If I then go over to 1, at 1 I'm at 0, and -3 I'm at 0. I'm going to go write these in. So this is -2, 0, -3. This will be -4. This is 1, this is 2. This was -3. This was -3, since it's symmetric, axis of symmetry. 0 and 0. Let's go plot these. So now I have enough information. If I wanted to, I could go check my value for 2. At 2, I'm at 5. So since it's symmetric, at -4, I'll be at 5. I can graph my parabola now. It's really rough. Still getting used to my drawing tablet for my computer again. But the point is, we see, I'm going to fix this a little bit. There we go. At -3 and at -1 for x, I have my solutions. So my solutions are x equals 1, because at x is 1, y is 0. It's where our parabola intercepts the x-axis. And also at x equals -1, -2, -3. For range, I always know it's y. I'm going to keep my smile. So here's our math emoji. And then my vertex is at -4 for y. So if I start to the left, I'm above -4, I'm approaching -4, getting closer, getting closer, getting closer. I hit -4, and once I touch -4, I go back up. Okay. Now, for the discriminant for 2a and 2b, discriminant d is equal to b squared minus 4ac. For a is 2, b is 5, c is 1. We want to check if d is greater than 0. If so, we have 2. If d is equal to 0, we have 1 solution. If d is less than 0, we have no solution. Well, I have this already set up too. So let's go over 2, 5, and 1. Let's change. And I can actually, before I even do that, if we look, Number 7 is the discriminant. Number 8 is one solution, and number 9 is the second solution from before. So for 7, our discriminant is a positive, so we have 2 solutions, which is true. Now I have 2, I have 5, I have 1. For here, all we need to do now is, all I want to know is how many solutions I have. So I go to d equals b squared minus 4ac. I see d equals 17. I'm going to write this down. Well, 17 is greater than 0, so there will be 2 solutions. For b, I know a is 2, b is negative 3, c is 5. I'm just going to go plug these in to the app. So 2, negative 3, 5. Let's check. D is negative 31. My solutions are undefined because there are no solutions. And if we look again, D is equal to negative 31. Well, if we look, D is less than 0, so there are no solutions. Okay. 3 is a different form. 3 is in vertex form instead of standard form. For vertex form, all we need to do is find the vertex. Vertex form is really nice because it tells us the form for the vertex. So vertex form is written as y is equal to vertex form is equal to y equals a parentheses x minus, I like putting h in parentheses so I can tell if it's a plus or minus h, squared plus k. And then the vertex is just h comma k. In this case, I do not have a negative h because I can put parentheses around this too and have the correct form. So I have 3 for a, x minus 2. So my vertex, my k is 1, my h is 2. So I have my vertex at 2, comma 1. Now, for 4, all we are doing is looking for roots. Remember, roots are also solutions or zeros. So you are trying to find, let me go back to the other graph, the points where a parabola intersects the x-axis, which we know from S1 and S2. These use the quadratic formula. I've got 2 forms. I have negative b plus the square root b squared minus 4ac all over 2a. And then I have the subtraction form. So negative b minus the square root b squared minus 4ac all over 2a. So for those 2, all you need to find, and this is where you should pause and try and work this out on your own to get used to the app, is find a. Let me change the color. Let's do a blue. So a equals, b equals, c equals. So find those three, and then find your solution. So I'm going to do S1, and I'm actually going to write this as x equals or we'll be consistent. We'll use S. I don't want to confuse us right now. So solution, my solutions are x equals, comma, x equals. And do the same for over here. Have A, B, C, and then solutions x equals, x equals. Practice this. See what you get in the app when you find A, B, and C. Alright, I'm going to assume you pause this for a moment. So now I'm going to solve these out. So in this case, A is 3, B is -4, C is 1. Let's go plug these in. 3, -4, 1. Oh, my solutions are at 1 and 0.3 as a decimal. So I'm going to go ahead. I'm going to write these out. So I have 1 and 0.333. That just shows it's repeating. And if we look on the graph, we see it at 1 intersecting the x-axis. And if I were to click here, it'll show me at 0.3. Great. So now for the second one, A is 2, B is -4, C is -6. Go back on over. 2, -4 doesn't need to change, -6. Scroll down to our solutions. We've got a solution at 3 and a solution at -1. Perfect. Alright. Most recently, we had worked on projectile motion for a long time. To remind us projectile motion, well, if I'm throwing a ball, the ball will never go underneath the ground. So projectile motion always starts at 0, goes up, comes back down, and touches the ground. We only ever care about a solution after 0, and we also want to know maximums. For here, again, let's just go and find our ABC values. So A equals -16, B equals 101, C equals 10. Type in -16, type in -101, type in 10. It's hard to see right now. If I zoom out, I didn't make this a -16. There we go. That's better. I can change my zoom somehow. Here's what it roughly looks like. I can find my solutions if I click on the graph. So for starters, I see my maximum height, if I were to look at the point, is at 169 feet approximately. This is found by getting the vertex. So using that -b over 2a to get the x, and then plugging that in to get the y. In this case, it's already shown for you. So we can go on over. We know the maximum height is at the vertex, which was 169 feet. I'm going to skip B for a moment. I'm going to go to the other easy part, which is C, how long it takes to hit the ground. As I was saying, we only care about positive solutions. So look, solution 1 is negative, so that's no good. Solution 2 is positive, 6.4 seconds. If I click the graph and I look at 6.4, or I look at the solution at 0, x is 6.41. So it takes 6.41 seconds. We did this in the TI using the second trace and finding zeros. So this is our 0, or a solution. We found the 169 feet in our calculators using second trace maximum. Now, this one's a little rough for me to show. In your calculator, it's easier. You can use the table to find when x is, or to find the height when x is 3. I don't have to zoom in. Well, I know here's 3.15. Let's go on over to 3. So it's not letting me get to the 3 exactly. So what I can do, I can substitute, I believe I can add a statement x equals 3. Alright. For here, what I would be able to do is just plug in 3 for x. And get my answer of exactly 169. Whereas before we had a little bit more. We had 169.4. I put these back to x's. So I'm going to change this one to be 169.4. And this one will be 169 feet. Okay. Last but not least, a couple of people were out for this one. So for here, we are trying to use the graph to find an equation, the solutions, and the minimum. If we look, it intercepts the x-axis at, well, this is 4, this would be 5, and this would be 3. My solutions then are x equals 3, x equals 5. For the equation, we want the opposite. So I should have one solution. This is solution 1. This is solution 2. I'm going to do this one in purple, or bluer. This is. So let me go back. Here's S2. So I want the opposite of 3. The opposite of 3 is negative 3. I want the opposite of 5, so I want minus 5. This is our equation. That's it. Once you have your solutions, take the opposite with the parentheses. Now the minimum, if we look, is, I'm going to change this back to black. It's about there. So this occurs at 4. Remember, a minimum is the y value. we could write this as a vertex if we wanted to, but the y value would be the actual minimum. So every 2 lines in this case is 1. So this is -1. So our vertex is for -1, so our minimum is equal to -1. And that's it. I'll have these materials posted soon, and there will also be the study guide and the blank sheet for you. Take care.